moments of thinking this is going to happen more and more. So get ready for it. Get ready. So good in this just read about five papers system 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 system. Maternal supply system alleviates oxidative stress and enhances angiogenesis in porcine placenta. Angiogenesis. Angiogenesis. Angiogenesis placenta. Angiogenesis placenta. The results indicated that oxidative stress and impaired angiogenesis might contribute to the occurrence of low birth weight piglets during pregnancy, and cysteamine supplementation at 100 mg per kilogram during late gestation and lactation of sows could alleviate oxidative stress and enhance angiogenesis in placenta, thereby increasing birth rate in low-yield sows and reducing stillbirth rate. The in vitro data showed that the underlying mechanism for positive effects of cysteamine might be related to activation of ST3 in P3ECS. Introduction. Pregnancy is an oxidative stress challenge for the mother, especially during the late gestation period, when the rapid development of the fetus increases. The metabolic burdens on pregnant sows and dams, leading to alleviated systemic oxidative stress. When the rapid development of the fetus increases, the metabolic fetus increases. The rapid development of the fetus increases the metabolic burdens on pregnant sows or dams, leading to elevated systemic oxidative stress. Increasing evidence indicates that maternal oxidative stress is associated with several adverse outcomes. Increasing evidence indicates that maternal oxidative stress is associated with several adverse outcomes such as gestational debates, mellitus, proteinuria, preeclampsia, postmortem, hemorrhage, fetal death, and low birth weight. Increasing evidence individuals Increasing evidence indicate that the maternal oxidative stress is associated with several adverse outcomes, such as gastrointestinal debates, Thus, reducing oxidative stress is a crucial issue. Reducing oxidative stress is a crucial issue for improving the reproductive efficiency of both humans and mammalian animals. Reducing oxidative stress is a crucial issue for improving the reproductive efficiency of both humans and mammalian animals, but its underlying mechanisms still remain elusive. Pregnancy is an oxidative stress challenge for the mother, especially during the late gestation period, when the rapid development of the fetus increases the metabolic burdens on pregnant cells or dams, leading to elevated systemic oxidative stress. Increasing evidence indicates that maternal oxidative stress is associated with several adverse outcomes, such as gestational diabetes, mellitus, proteinuria. The placenta regulates fetal nutritional and hormonal supports, which is to a large degree has a direct impact on the pregnant outcome. In particular, placental blood vessels play an important role in maternal-fetal material exchange, suggesting the importance of proper placental vasculature development for fetal growth. Moreover, the placenta is highly sensitive to oxidative stress, which could cause vascular dysfunction in the placenta. Moreover, the placenta is highly sensitive to oxidative stress, which could cause vascular dysfunction in the placenta. Our previous studies have uncovered that increased oxidative stress induced by maternal obesity may decrease the development of placental vasculature essential for fetal growth during pregnancy. Our previous studies have uncovered that increased oxidative stress induced by maternal obesity may decrease the development of placental vasculature essential for fetal growth during pregnancy. Suggesting that the involvement of placental oxidative stress in the development of adverse pregnancy outcomes. Mechanically, an increased amount of reactive oxygen species could induce autophagy, dysfunction, and apoptotic death of vascular endothelial cells. The foregoing reports indicate that targeting the placenta could be an attractive strategy for modulating oxidative stress-related pregnancy diseases. Dietary intake of antioxidant nutrients to improve the endogenous antioxidant defense capacity has been considered a plausible way to prevent oxidative stress. Plausible. It's a plausible way to prevent oxidative stress. Cysteamine, a brace culture precursor of glutathione. Precursor of glutathione. Precursor of glutathione. Precursor of glutathione is widely used to protect a series of tissues and organs such as the gastrointestinal tract, brain, and kidney from oxidative stress under adverse conditions. Oxidative stress. We select the CS based on its multiple beneficial modes of action. We selected cysteamine based on its multiple beneficial modes of actions. Example, cysteamine could improve ileal mucosa health by regulating the oxidation status. Apoptosis in finishing. L-cysteine, one of the downstream metabolites of cysteamine, could efficiently reduce the inflammatory response in the maternal-fetal interface and improve the placental efficiency in breasts. One of the downstream metabolites of CS could efficiently reduce the inflammatory response in the maternal-fetal interface and improve the placental efficiency in breasts. In this regard, cysteamine appears to be a promising candidate for alleviating maternal and placental oxidative stress. However, no data was available currently regarding the effect of dietary cysteamine supplementation during gestation and lactation and the reproductive performance and antioxidant status of cells, especially the dose-effect relationship. In this study, we addressed the hypothesis that cysteamine could enhance placental angiogenesis by alleviating maternal and placental oxidative stress and ultimately benefit the survival and growth of the fetus. Survival and growth of fetus. Survival and growth of the fetus. However, no data are available currently. No data are currently during gestation and lactation on reproductive performance and antioxidant status of cells, especially the dose-effect relationship. In this study, we addressed the hypothesis that cysteamine could enhance placental angiogenesis by alleviating maternal and placental oxidative stress and ultimately benefit the survival and growth of the fetus. Thus, the purpose of this study was to evaluate the effects of cysteamine on cells' reproduction performance, antioxidant status, and placental angiogenesis through an in vitro, in vivo methods, materials and methods, animals and experimental design. This study was conducted in Guangzhou, Hebei, Long Agri-Animal Husbandry Science and Technology Corporation Limited. A total of 84 landless in New York, South, Article 225, were allocated to 4 dietary treatment groups, which saw as a replicate in a completely randomized design using body weight at day 85 of gestation. As a block, the cells in the control group received a basal gestation or lactation diet without added cysteamine from day 85 of gestation to day 21 of lactation. The cells in the control group received a basal gestation or lactation diet without added cysteamine from day 85 of gestation to day 21 of lactation, while the cells in the cysteamine group were fed a basal diet supplemented with 100, 300, or 500 milligram per kilogram of cysteamine. All diets were formulated to meet the National Research Council requirements of nutrient standards for gestational and lactational cells. The ingredients and compositions of basal diet are shown in supplementary table S1. Cells were housed in individual stores and fed twice a day with a constant amount of 3 kilograms during late gestation. During the entire lactation period of 21 days, the piglets had no access to sow feed or to creek feed. Sows and piglets were given free access to water throughout the experiment. On the day of farrowing, sows were offered 2.0 kilograms of lactation diet, followed by increasing the amount to 3.0 kilograms daily until ad libitum feeding. The reason for sows eliminated from this study were recorded in detail and shown in supplementary table S2. The reason for sows eliminated from this study were recorded in detail and shown in supplementary table S2. Measurements of reproductive performance and sample collection. After farrowing, the number and weight of piglets born alive, stillbirths, and mummies were recorded, and invalid piglets included stillbirth and mummy. Piglets were weaned at 21 days of lactation. During some farrowing, umbilical cords were tied with a short silk line, and each piglet were marked with a numbered tag to match the individual piglets with their placenta. Umbilical cords. umbilical cord, umbilical cord, umbilical cord. Umbilical cord. After varying the number and weight of piglet born alive, stillbirths and mummies were recorded, and invalid piglets included stillbirth and mummy. Piglets were weaned at day 21 of lactation. During self-bearing, umbilical cords were tied with a short silk line, and its piglets were marked with a number to match the individual piglets with their placenta. Each short line and each piglet was marked with a number tag to match the individual piglets with their placenta. During the bearing, umbilical cords were tied with short silk line, and each piglet was marked with a number tag to match the individual piglets with their placenta.